Welcome to Checo International. I am Nilamarjana speaking. This is analog and digital electronics for engineering preliminary. A semiconductor is a material that has the resistivity somewhat between the good conductor and that of insulator. Semiconductor have another very important property. The resistivity or conductivity of semiconductor changes considerably when even minute amounts of certain other substance called the impurities added to them. Semiconductor materials are non-linear resistors. Most semiconductor materials used in electronic industry have negative temperature coefficient. Within any given material, there are two distinct energy bands in which the electron may exist. These two energy bands are valence energy bands and conduction energy bands. The distinction between conductor, insulator, and semiconductors is large in concern with the width of the forbidden energy gaps. There is no forbidden energy gap in case of conductor, 1 electron volt in case of semiconductor, 5 electron volt in case of insulator. Two basic charge transport mechanisms are drift due to applied electric field and diffusion due to density gradient. The bonding of atoms strengthened by sharing of electrons between neighboring atoms called covalent bonding. Covalent bonding arrangement exists in silicon and germanium. The number of free electrons per cubic meter metal whose energy lie in interval between E to E plus delta E is given by D and E, rho is E and D. Rho represents the number of electrons per volt meter cube, number of electrons per electron volt per meter cube of metal, and expressed as rho is equal to NeFe. N is the density of states in the conduction band. Intrinsic material are those semiconductors that have very low level of impurities. For the extrinsic materials, the semiconductors that have been exposed to doping process. Silicon and germanium are two most widely used semiconductor materials in electronic industries. At absolute zero temperature, the electronic gap Eg for silicon there was a 1.21 electron volt and 0.785 electron volt. Depending upon the type of impurities added, extrinsic semiconductor can be divided into two classes: N type of semiconductor and P type semiconductor. A N type of material is formed by adding donor atoms such as arsenic, antimony, bismuth, phosphorus that have high valence electron to establish a high level relative free electrons. In N type materials, electrons is the majority carrier, hole is the minority carrier. In P type materials formed by adding acceptor atoms such as boron, gallium, indium, aluminium, the three valence electrons to establish a high level of holes in a material. In P-type material, the hole is a majority charge carrier, electron is a minority charge carrier. Under the thermal equilibrium, the product of concentration of free electrons and concentration of holes is constant and independent of amount of doping by donor and acceptor impurity. This is known as the mass action law. N into P is equal to Ni square. And P is equal to Ni square N, Ni square by Nd, Nd the constant of a donor atom. Metal semiconductor junction also form ohmic contact, which are the low resistance junction providing conduction both direction with very little voltage of axial reduction and applied reverse voltage, bias voltage across. Increase the potential barrier, increase the space charge weight, and increase the magnitude of electric field. A forward bias PN junction at a positive terminal applied to the P side and negative to the N side. Reverse is true for the reverse bias. That means a negative terminal to the P side and positive to the N side. That is reverse bias. When the forward bias voltage applied across the PN junction, the potential barrier is low enough so that holes from the P regions and electrons from the N regions can flow across the junction. The space charge region or depletion region formed on either of the metallurgical junction separating P and N junction. This region is essentially depleted of any mobile electrons hole. A net positive charge density due to positive charge donor impurities ions exist in N regions, and negative charge density due to negative charge acceptor impurity ions exist in P region. The half-wave and full-wave rectifier circuit convert AC signal to an approximately DC signal. A DC power supply which is used to bias the electronic circuit and system utilizes such circuits. The half-wave rectifier is corrected by excessive ripple, small values of rectification efficiency, transformer utilization factor, and DC saturation of transformer core. Center type and bridge type of full-wave rectifier improves on the half-wave characteristics. With this, the present company like is subscribe, put the bell icon. Thank you.